Page 448, number 3. We're supposed to solve the triangle and the picture's given to us. And so in this situation, we're given side, 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 which is also a perfect situation for law of cosines. So I'm going to start by finding the cosine of angle A, finding the inverse cosine. So I'm going to do cosine of A is going to be C squared. Sorry, write that a little neater. C squared plus B squared minus A squared all over 2 times C times B. And again, I said this in the last video for number 1. You can verify how you can rewrite the law of cosines in this way so you can find an angle easier. So this is going to be 24 squared plus 19 squared minus 27 squared all over 2 times 24 times 19. So then I'm going to take the inverse cosine and I'm going to put that entire fraction into my calculator without doing any intermediate arithmetic, so it is a more precise answer. And when I put this in my calculator using the inverse cosine, I get that angle A is 76.8 degrees. Now I'm going to use the law of cosines again to find either of the other angles, and I'm just going alphabetically, so I'm going to find angle B next. So I'm going to use the same relationship. The cosine of angle B is going to be A squared plus C squared minus B squared all over 2 times A times C. So the cosine of B is going to be 27 squared plus 24 squared minus 19 squared all over 2 times 27 times 24. And again, I'm going to do the inverse cosine. And I'm going to put that fraction in the calculator like I did for angle A. And when I do that, I get that angle B is 43.2 degrees. And now what I can do is just subtract from 180 to get angle C. So it'll be 180 minus the 76.8 degrees minus the 43.2 degrees. And when I do that, I get angle C is 60 degrees. So here are my 3 angles, 76.8 degrees, 43.2, and 60 degrees.